For this review, I will go ahead and give you two different ways of graphing these equations. Remember, the first way we learn to graph the equations is by making a t-table, x and y, and we pick the numbers -1, 0, and 1. On this particular one, I'm still going to pick 0, but I'm going to choose -5 and a +5 because we're going to take 1/5 of x. So let's plug in -5 first for x. -1/5 times -5 is +1, and 1 take away 2 is -1. -1/5 times 0 is 0. 0 minus 2 is -2. And -1/5 times 5 is a -1. -1 take away 2 is -3. And so -5, -1 is right here, 0, -2 is right here, and 5, -3 is right here. Sorry for the line that's not exactly straight there, but remember that if we wanted to graph that using the slope-intercept form, we would first of all graph the y-intercept, which is -2. There's that point right there. And then we would go up 1 over 5, which gives us this point. We could also go down 1 to the right 5, which gives us this point. For number 2, if we make a t-table using the x and the y, then we have -1, 0, and 1. -5 times -1 is a +5. 5 minus 1 is 4. 0 times -5 is 0. 0 take away 1 is -1. And -5 times 1 is -5. -5 take away 1 is -6. So -1, -1 +4 is right here. 0, -1 is right here. And 1, -6 is right here. Connect those points. We have our line. If we're using slope-intercept form, we would first graph the -1, which is right here, and then we would go up 5, 1, 2, 3, 4, 5 to the left 1, or down 5 to the right 1. For number 3, I'll just use slope-intercept form. Since there is no y-intercept, I'm going to put my first point at 0, 0, the origin. The slope is -5/2, so I could go up 1, 2, 3, 4, 5 to the left 2, or I could go down 5 and to the right 2. It's a negative slope, so make sure that you check yourself that it's going in the right direction for a negative slope line. For number 4, I just want to start by reviewing the quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You can remember that it's in the shape of the letter C. And of course, this is the x-axis, and this is the y-axis. So to graph this one, we'll use slope-intercept form again. Go up 3. And there is my y-intercept, +3. And I'm going to go down 7, 1, 2, 3, 4, 5, 6, 7, and over 1. Remember that if that slope is just a number, you can always put it over 1 to make sure you know how far to do the rise and the run. Okay, of course I could go up 7, 1, 2, 3, 4, 5, 6, 7, but that's off of the graph. So I have the 2 points to connect right there. It's a negative slope going through the 4th and the 2nd quadrant. For number 6, I'll do the old-fashioned way of making a t-table using -1, 0, and 1 for my values for x. If x is -1, -6 times -1 is a +6. 6 plus 1 is 7. 0 times -6 is 0. 0 plus 1 is 1. And -6 times 1 is -6. -6 plus 1 is 5. So negative 1 up 7 is actually off the graph up here in quadrant 2. 0, 1 is right here on the y-axis, and 1, 5 is right here, and that tells me right away that I have a mistake because those 3 points obviously do not go in a straight line. So let me just double check my work. Negative 6 times negative 1 is positive 6 plus 1 is 7. 0 times negative 6 is 0. 0 plus 1 is 1. Negative 6 times 1 is negative 6 plus 1 is a negative 5. So this point right here was the one that was incorrect. So if I go positive 1, negative 5, that point does fall in line with my other 2 points. So number 6, negative slope using a t-table with the values negative 1, 0, and 1. Just realize I skipped number 5. I will do this one using slope-intercept form. Negative 5 is my y-intercept, so I come down here on the y-axis and put a dot there. The slope is a positive 2, so that means I go up 2 over 1, up 2 over 1. Here is my line for number 5. For numbers 7 through 12, I'll try to model these a couple of different ways. You're going to want to write the equation in slope-intercept form, which is y equals mx plus b. Probably the simplest way from using the graph is just to identify the y-intercept. So this is 4, so I'm going to put that in for my b, and it's positive 4. And then to find the slope, I want to find one other point on the line. So there's that one there, or I could use this one right here. To get from one point to the next, I have to go up 1 and over 3. Up 1 and over 3. So the rise is 1 and the run is 3. So my equation for this line equals y equals 1/3 x plus 1/4. For number 8, we have a vertical line, and you might remember that vertical lines have an undefined slope. And the reason why is because if I take any 2 points on the line, let's say 2, 2 and 2, negative 3, if I subtract the y values, which is the rise, negative 3 minus 2, and then over the run, the x values, 2 minus 2, what I get is negative 5 over 0. And we cannot have a denominator of 0, and that's why the slope is undefined. So for vertical lines, you're simply going to write the equation x equals and the number where it crosses the x-axis, in this case 2. The answer to number 8 is simply x equals 2. Now if we did have a horizontal line, let's say right here at negative 3, our equation would be y equals negative 3. So for a vertical line, we have x equals whatever number it is, and for a horizontal line, we have y equals wherever the line crosses the y-axis. For number 9, the y-intercept is negative 4, so in my equation y equals mx plus b, the y-intercept will be negative 4. Next, I'm going to take another point on my line and count up for the rise, 1, 2, and over for the run, 1, 2, 3, 4, 5. And again, that's up 2, over 1, 2, 3, 4, 5. So it's a negative slope, so it should be y equals negative 2/5 x minus 4. For number 10, it's a positive slope, so I know my m, or my slope value, will be positive. And it looks like the y-intercept crosses right here at negative 5, so I'll put that in for b. And the other point, it looks like where it crosses the line here is at 1, 2. So that's up 1, 2, 3, 4, 5, 6, 7 over 1. So that's y equals 7x minus 5. For number 11, this might get kind of tricky because some of the graphs, you can't tell exactly where it crosses the y-axis. So I'll try to be a little bit more clear on the quizzes and tests where those actually cross. For number 11, I'm going to say it crosses at 5, 0, 5. So 0, comma 5. And another point on the line I'm going to say is 1, negative 1. And I'm going to do this problem the longer way, just so you remember that you can do these problems a different way by taking the difference in the y values, or the rise. So I'll take 5 minus a negative 1 over the change in the x values, which is 0 minus 1. So what we have here is a positive 6 over negative 1. So the slope is negative 6. Once I have the slope, I can plug in negative 6 for b and negative 6 for m, and y equals mx plus b. And then I need two other values, an x and a y value, and I can either use this ordered pair or this ordered pair. The y value I'll put in is 5, so 5 equals negative 6. The x value I'll use is 0, plus b. Negative 6 times 0 is 0, so we get a y-intercept of 5. So the final equation is y equals negative 6x plus 5, and we can check that by the y-intercept is 5, there's that point right there, and then a slope of negative 6 would be down 1, 2, 3, 4, 5, 6, and over 1. Number 12, I'll also do the long way by identifying 2 points in this point, or this graph, 0, 5, and 2, 0. So we have the change in the y values, 5 minus 0, over the change in the x values, 0 minus 2. So we have a slope of 5 over negative 2. So when I substitute in y equals negative 5 halves x plus b, I need to find one ordered pair. Let's just choose this one right here, 0, 5. The y value is 5, so 5 equals negative 5 halves times 0 plus b. Negative 5 halves times 0 is 0, so my b value, or my y-intercept, is 5. So the final step is to plug those two into the y equals mx plus b slope-intercept form, which would be y equals negative 5 halves x plus 5. And we can double check that. The y-intercept is 5. And then down 1, 2, 3, 4, 5 over 2 is that point right there. Some final review problems for your quiz on Tuesday. Just make sure that you're able to graph points on the coordinate plane. That should not be a problem. And make sure that you know which quadrants are which. Those should be easy points. And then x and y axis, you should be able to determine whether a point is on the x or the y axis. You should also be able to calculate the slope between 2 points. And so here's an ordered pair, and here's an ordered pair. And all you have to do is subtract the y's, 3 minus 8, and subtract the x's, 2 minus 5. It doesn't matter if you take 8 minus 3 or 5 minus 2 or vice versa, you still get the same answer. So in this case, negative 5 over negative 3, so the slope is 5/3. Also for the quiz, you have a couple of graphs where you have to just find the slope. And the slope is really easy to find. Just find 2 points on the line, count up and over, and write your slope in simplest form. Remember that a negative slope is going to go in this direction and a positive slope is going to go in this direction. So after you find that rise over run, make sure to put the positive or the negative with it. Also, some very easy points on the quiz. When I tell you m equals 1/5 and b equals 4, to put that into slope-intercept form, y equals mx plus b, all you have to do is put in the m value, which is the 1/5, and the b value, which is 4. Those should be very easy points to get by just substituting in the values. You have 4 problems on the quiz where you're given a graph and you have to write the equation for the line using slope-intercept form. Remember, slope-intercept form is y equals mx plus b, so you can identify the b on where the line crosses the y-axis. Okay, so let's just say that's a positive 2, and then to find the m value, you just need to count up and over, or up and over, to find what that m value is. You can do it the long way by identifying 2 points on the line and calculating that by hand, but if you're given the graph, all you have to do is find those 2 points and count up and over to find the slope. To find out whether an ordered pair is a solution to an equation, you have something like y equals 3x plus 2. And is the point 0, 3 a solution? Well, you plug the 0 in for x and the 3 in for y. Is 3 equal to 3 times 0 plus 2? No, it's not. So no, this is not a solution to this equation. Don't let it throw you off if the equation is in a different form, like 2x plus y equals 5. Is the ordered pair 1, 3 a solution to this equation? Well, 1 goes in for x, 3 goes in for y. 2 times 1 is 2, 2 plus 3 is 5. So yes, this is a solution to the equation. Remember, when you're graphing linear equations, you can graph them using a t-table by picking numbers for x and substituting it in and finding values for y. Or you can use slope-intercept form, which is going to find the y-intercept first and then using your rise over run to find another point to graph it. There's only one of them like these on the quiz, and so you might want to just do it slope-intercept form and then double check it using the t-table to see if you get the same points. The final 2 problems are given to you in slope-intercept form like this, and it asks you what the slope is and what the y-intercept is. In this case, the slope is negative 2/5 and the y-intercept is 2, and then to graph that we would go up 2 and put a point, and then down 2 over 5, or up 2 to the left 5. We have a line like that. Hopefully these problems help you review for the quiz on Tuesday. And if you need any extra practice, you can always go to the online quizzes and type in ACA 0301, 0302, 0303, or 0304.